Welcome to the session. Greeting of the day. In today's class, we are going to talk about the plastic deformation processes. We are dividing into two categories of a bulk deformation categories process and a sheet metal deformation process. Both are deformation, but I am using the word one for bulk deformation, which is we are going to use for more thickness, high thickness materials. And one more I am telling as a sheet metal deformation process is we are going to use for less thickness materials. So the sheet metal process we will see later. As of now, I am starting with the bulk deformation materials. So you see, this is how the various topics that we are going to see. In such a way, I am dividing the plastic deformation of the metals and alloys, and there we are going to say about how this deformation is going to happen. Maybe it may be a hard working process. After heating, at a red hot condition, we are going to deform into the other shape. That is one part. Or otherwise, without heating, a cold deformation process. This is one, and this is to cold deformation process. And then we have to see about over hardening and annealing treatments. There I am dividing this bulk deformation process. The word comes here, the bulk, a large thickness materials. I have taken here about these three categories of forging and its types. Forging and its types. It is one of the bulk deformation method. Forging treatments. And there this smith forging, drop forging, roll forging process are there. And later, one more bulk deformation process as a rolling treatments, and their types of rollings and mills are there. And later the same bulk deformation of extrusion and types. So these three we are going to types of extrusions, and these three we are going to see in the upcoming sessions. So number one. So how it will in general, how we can understand, I have talked about the 3 points there of forging, rolling, extrusions. You see, rolling, first a forging treatment, we have a die process. It may be one is a fixed die, and we want to do a forging treatment where forcefully pressing action has been done, and the metal which is at the hot condition, hot working process, it is deformed to the other shape. So I have kept this workpiece, at center, and I am giving the force here, with respect to the other die, and I am pressing. This is generally a forging, and then you have to see some other types. Keeping the workpiece at a hot working condition or cold working condition on the die, in between the die, and we are pressing. Forging action. In the next one about this rolling forging, about the rolling action, you see, we want to reduce the thickness of the specimen. There the shape itself is changed. But here, I want to lightly reduce the thickness of the specimen. Here I have a large thickness of the specimen, and I have a rollers. Which is going to make the forward by the drag movement of this specimen in the other direction. I'm sending the workpiece here. These rollers are rotating in the clockwise and anti-clockwise, and therefore it is going to drag the specimen inside with respect to applications of force here above. With respect to applications of force here, what happens with respect to application of force here? This is pressing along with the dragging. It is also pressing the specimen in such a way, this large thickness of 10 mm, this large thickness of 10 mm specimen converted into maybe 8 mm, it has been reduced. Such a way, thickness reduction we can use rolling. That is also one of the plastic deformation of the material. Deformation from the large thickness to the low thickness. The deformation from the different one shape to the other shape. That is about forging and the rolling. And later we have seen about this extrusion. Extrusion contains maybe a solid extrusions Otherwise, the wires or tubes or bars we have seen, hollow pipes, those extrusion process are there. So this all we have to see. So extrusion is nothing but a conversion of the large thickness billet converted in terms of a pipe or large bars. So those things, extrusions and wire drawings to be seen. So this, if we are completing this 4 topics, our bulk deformation process classifications will be completed. So that's one by one we will see. Now first we will go. Plastic deformation processes. The operation that includes shape changes on the workpiece. We have taken one workpiece, we are doing the shape change here. We are doing the shape changing process by plasticizing those material. Plasticizing the material and deforming under the force. Deforming under the force applied by various tools and dies. Various tools and dies we are used here. You see, we are using the die here, we are using the roller here. So such a way we are using this ramps and pistons processing action. So tools and dies we are using to change the shape, change the thickness, any from deformations are occurring. So bulk deformation process. This process involves large amount of plastic deformation. So here we are using the word large amount of plastic deformation. The cross section of the workpiece changes without volume changes. As it is 100% volume is here. What the thickness we have taken, it is compressed only. It is not removed. Therefore 100% material is inside only. Volume is the same. Shape only, deformation is changing. Only we are cross section is changing. Without volume changes. We are not terminating, we are not cutting. The ratio of cross section area to the volume is small. Performed as a, maybe we can perform this bulk deformation process as discussed at the first point. Maybe the cold working process, maybe the warm working process, maybe the hot working operations. In general, we can tell 2 words of cold working, hot working operations, because warm comes under automatically it is getting hot. Therefore, we are understanding these things as a cold working treatment, hot working operations. So hot working, cold working can be performed for maybe for rolling, hot working of rolling, cold working of rolling, hot working of forging, cold working of forging, hot working of extrusion, cold working of extrusions, hot working of wire drawings, cold working of wire drawings can be done. Now I want to classify this temperatures with respect to hot working and cold working conditions. You see, there is a term of melting point temperature, temperature of melting. This I am mentioning as a Tm. And now from the melting temperature it is 0.75 only, and from 0.5 to 0.75 I am mentioning this as a hot working conditions. Here it is ambient temperature, and from ambient temperature to 0.3 times of melting temperature of the metal. I am considering this as a cold working conditions. For steel, 1500 as a melting point. 1500 as a melting point. So on that 0.75, on that half is about 750. About 750 degrees centigrade. And on that 0.3, how much? So maybe 300, 400s. So along for that up to it is cold working treatment. Then up to 750 it is warm working treatment. Up to, we are dividing here, we are dividing like this. And so accordingly we should have a look. See, ambient to 0.3 I am understanding is a cold working process. Then 0.2 to 0.5 is a warm working process. And 0.5 to 0.75 it is a hot working process. After 0.75 what happens? It is ready to melt. It will be collapsed more. It is going to get a fluidity operations. Therefore, the operations what we want to do, maybe hot or cold working, we are stopping here. We are doing the operation at 0.75 times. itself, maybe 1100 points out of 1500, maybe 1100, maybe 1000, likewise. We can able to consider. So 0.75 maybe 1000 degree centigrade, likewise we can take. So such cases. The temperature range of a different metal, it changes with respect to different metal. So 1000, it's not a fixed material, fixed temperature for all, not for alloy, not for aluminium. I have mentioned here for 1500 for steel, carbon steel, mild steels. So likewise, so it differs. The temperature range of different material forming operations of ambient is the ambient room temperature, and Tm is the work metal melting temperature. So this is the melting temperature, this is the ambient room temperature. So from there in between it is going to differ. Now this small one point I have to add here about the cold working process at room temperature. What are the advantages here? In the cold working we are doing the forging, in the cold working we are doing the rolling and the extrusion process. All these things. In general we are talking about the comparison of cold working treatment and warmer. Cold working treatment may be the hotter. So these things we have to see. In the cold working conditions, when the operation is cold working, when the operation of rolling is in the cold, when the operation of forging is in the cold, we will get better accuracy. We are getting better accuracy, better surface finish, high strength and hardness we are getting. You see, at cold working process, heat is not involved. The heat is not involved, we are not going to cross the critical temperature of the material. If the critical temperature has been crossed, there is more chances to change in the microstructure. We don't know which microstructure is going to form. Maybe martensite is forming, it is a very dangerous microstructure. Those things, dendrite, if it is forming, it is dangerous microstructure. Those things we are going to avoid when the working has been done at the cold working conditions. So cold, it is a good high strength we are getting. No heating is required. Very important point, because you see, even 1 degree of increase in the temperature is very difficult, cost effective. We need ovens or we need furnace to keep heating. It is such much difficult. Therefore, heating is not required. Obviously, it is getting cost reduction. Obviously, we are getting high strength there. Then it is okay. But what is the disadvantage here? We need high force is needed. High force. Why? When it is red hot condition, it is readily deformable. It is readily deformable. But when it is not in hot condition, it is not ready. It is very hard condition. You have to hit more and more. The force is more required to convert this one shape to another shape. But in such a case of red hot condition, it is readily deformable. I am giving a less force. In such a way, we can able to bend easily. Therefore, it requires high force and powers. Limitations to the amount of forming and addition annealing may be required. Why is annealing? Annealing we are doing for stress relieving operations, uniform microstructures. So that and all we are doing. Why? Here we are hitting. Stresses are formed. Therefore, the stresses to be relieved by maybe by the heat treatment process. Those things are needed for the cold working advantages and disadvantages. What is in the warmer conditions? Warmer condition is a little bit hotter. If it is hotter, little bit force giving maybe reduced. So lower forces are there and powers, and easily we can able to change the shapes more easier than that of the cold one. So cold is lesser than that of the shapes in terms of changing the shape. When it is coming to hot working operations, that is okay. So some disadvantages, some investments and furnaces are required because we are getting hotter. So furnaces investments high cost. Now we came to the same same what point we have discussed here for the cold working. For the hot working operations, you see the material temperature above recrystallization temperatures. Above the recrystallization temperatures. What are the advantages now? We are getting big amount of forming is possible. If it is heated, the large workpiece also can be changed in shape easily. at less force. So that is what a big amount of forming also possible. Lower forces, you see, lower forces. Next point, both are related. Lower forces and powers are required. Materials with low ductility, no work hardening are required. Therefore, no additional annealing. Here in this term, we have used the annealing word. You see, annealing we have did. Here we have did, but it is no annealings are not needed because it is already in the we are doing the operation itself in the high temperature. Already a little bit stresses are going to relieve at high temperatures. Therefore, annealing may not be needed. So disadvantages: low accuracy, surface finishes, low surface finishes, higher production cost. Yes, high production cost because furnace we are using high temperatures, and then shorter lifetime. So maybe furnace shorter lifetimes may be occur. So you see, low accuracy and surface finish. What is that point? When it is readily deformable, I want to change the shape of 0.1 or 1 mm changing of shape or changing of thickness, reduction of thickness I have to do. What I am doing, let us consider the rolling treatment. I have kept inside force applied in the cold working conditions. I know what force I am applying to convert as 1 mm reduction. But now it is the same force is applied, but the material is at the red hot condition and it is readily deformable. For the same force applied, when the red hot material is going inside, it will deform more. Instead of 1 mm, it is going to deform 2 mm. Therefore, accuracy may not be maintained in terms of hot working conditions. For the same load, the cold is performed, hot is performed, hot material is going to deform more. So some accuracy will differ with respect to the constant load. Therefore, we should plan how much force should be given. In such a way, we will receive the exact output. So therefore, some of the low accuracies will be maintained, will be output. Now we will start with one by one. After rolling, we have to see, next forging and extrusions we have to see. So the deformation process in which work thickness is reduced by compressive force. Work thickness we are going to reduce. This thickness we are reducing by compressive force. The rolling process of, especially for flat rolling. This is about our flat rolling operations. The thickness reduction. I have used the two rollers. The top roller is rotating in the anti-clockwise direction. The bottom roller is rotating in the clockwise direction. In such a way, this pushes the specimen, and here you see, here the large thickness is there. This thickness has been reduced here. This thickness has been reduced there, and we are taking out. So such possibilities are possible. So this is how some images I want to show you. That is, see the roller, how the roller setup is there, and how we can able to look over. You see how they are making the rolling operations, coming inside and going up there. Plate thickness has been reduced. So such examples. The rolls. Now we want to see about the different type of rolling operations. What are we are going to do? See, based upon the workpieces, we could have a flat rolling process or with the shape rolling process. Until now we have talked about rolling itself for thickness reduction. That is a flat rolling. So this is what we have mentioned here about a flat rolling process. So thickness, a flat, it is going straight flat, thickness reduction. You see, a rotation of rolls perform two main functions. What are they? The roller is going to rotate now. So this roller is going to rotate. These rollers are going to rotate. What it does? Mainly it is going to compress. Pulls the workpiece into the gap. Pulls the workpiece into the gap between them by friction happening. By the friction between the work part and the rolls. So we have rolls, two rolls, this and the one more workpiece is going to in contact here. The workpiece is going to be in contact here. The workpiece is going to be in contact here. So therefore it is going to compress. So this zone is a contact zone. So this zone is the contact zone, we can understand. So this zone is the contact zone. So you see, this zone is the contact zone where it is going to compress, friction is going to happen. Simultaneously we are giving the force also here, pressure. Squeeze the work to reduce the cross section. So this is also happening. The remaining part of the subject, we'll see you in the next session. Thank you.